The first shape we're going to start with is a rhombus. And if you remember, a rhombus is a parallelogram. So automatically, opposite sides of this are parallel. Opposite sides are congruent. Opposite angles are congruent. Opposite consecutive angles are supplementary. And the diagonals will bisect each other. So all of that is still staying true when we come to this shape. What's unique about this shape, about a rhombus, which hopefully you remember, pretty sure kindergarten, my daughter knows this, is that all the sides of a rhombus are congruent. So all congruent sides. What does that mean? That each one of these are exactly the same in a rhombus. Okay? And that's really your major property, because if you think about it, if you were to describe this to a kindergartner, you would say, I have a shape and all four sides are the same. What you have to be careful about is, why couldn't your brother or sister say, well, that's a square? Well, you're right, because in a square, all the sides are congruent. But what makes it different than squares? Well, let's look. First of all, if you check out this diagonal, these diagonals are definitely not the same. Now, one thing I know about these, obviously, I already know they're the same. This piece and this piece are the same. I already know that because it's a parallelogram. Well, the new thing that's going to come into this is that the diagonals are perpendicular. Diagonals are perpendicular. Okay. So inside, what's kind of unique now is that I have 4 right triangles. Okay, so that's definitely going to be mathematically for us to use later, because all our stuff about right triangles now that we have those. So now I have 4 right triangles. The next thing I need you to know, and it's kind of a weird way to word the property, we know this angle and this angle. Well, in a rhombus, opposite angles are bisected. So what now we do is that this angle and this angle and that angle are going to be the same. Okay, so now let's say remember we have a right triangle. So if I said this was, let's just say 30 degrees, well, so is this, and so is this, and so is this, and this is 90, now makes these 60, 60, 60, 60. So inside the rhombus, we have to remember that these corners are all the same. So it's kind of a hard way to word it, but we say that opposite or bisected or bisect each other however you want. Okay, so let's quickly go through, because we got a lot to do. So let's look at this. Take a second, read it. You just want to be careful. Do diagonals bisect each other? Yes. Are the opposite sides parallel? Yes. Are they supplementary and the diagonals are perpendicular? Which are the true? All of these are true for the rhombus. Okay. All right. True or false? All rhombuses are parallelograms. Absolutely true, because it's under it. If you go back to the flow chart, one thing you want to realize, anything below, anything above it in the same family. Remember, trapezoids and kites are separate from parallelograms. So is a parallelogram a kite? Never. Is a parallelogram a trapezoid? Never. But if is an isosceles trapezoid a trapezoid? It's always. Is a rectangle a parallelogram? Always. Is a rhombus a parallelogram? Always. Does a parallelogram have to be a rectangle? Sometimes, not always. Okay, just like if I say, does a quadrilateral have to be a kite? Sometimes. It could be a parallelogram, could be a trapezoid, but is a parallelogram a quadrilateral? Always. Okay, and then the only one that's kind of tricky is rectangle and rhombus are next to each other. So if I said, is a rectangle a rhombus? It's sometimes. And when is it? It's when they're a square, because a square is really a rhombus and a rectangle smushed together or having a baby. Okay. True or false, all parallelograms are rhombuses, and that's false, because a parallelogram could be a rectangle or a square. Okay. And then let's check, this just goes back, which are true for all parallelograms. So this is something that every parallelogram has to have. All its sides are congruent? No, right? That's only in a rhombus. Diagonals are perpendicular bisectors? No, they're bisectors. They're only perpendicular in a rhombus. Diagonals bisect opposite angles. That's only in a rhombus. And so definitely not all, and opposite angles are congruent. That is true in all parallelograms. So here's where it gets tricky. You do have to know your properties. Okay. All right, here is our first math problem with the diagonal. With a rhombus. Given a diagonal, I'd like you honestly to pause and see how far you get on this without my help. All right, I hope you paused and did try this by yourself. So one thing I'm going to realize is it is a rhombus, so I'm going to keep that in mind. So automatically I do know that's 7, and that's only because in any parallelogram it's 7. So I need WY, so that's pretty easy, 14. Remember, ZX in this problem has nothing to do with 7 or 14. What I do know is inside here is 90 degrees. So I do know I have a right triangle and that I have a side length of 7. So if I could get a angle in here, I know I could use trig. So let's look at what else I need. In a rhombus, I know if this is 34, that this angle's cut in half. So this is 34. And because opposites are the same, this is 34. And now I also know that these angles are 56 and 56 up here. So right away, I could find all the angle measures. So WZB is 34, and XYZ is actually 112. This is 56, so this is 112. And now I need XY, which is definitely going to be trickier. Here is what I'm looking for, X. What I'm going to realize is I have a right triangle, and if you need the letters, this is X, this is Y, so this is where my X is. I know that this was V, so I know VY was 7, and I know down here's 56 degrees, or you could have used 34. Here's where you have to bring back your right triangles. Here is the angle. I have adjacent and the hypotenuse. So I'm going to do cosine of 56 is 7 over x. This is the one that's going to give me 7 equals cosine of 56, times x, and I'm going to divide by cosine of 56. So 7 divided by the cosine of 56, remembering the mode on our calculator. And if I'm in the right mode, I'm going to get 12.5. So the outside of that rhombus is 12.5. So this is the fun part. These are what we're going to do mathematically. Everything else is really going to be property based, but when we get into the math, you need to be able to fill these in. If you don't know your properties, you're going to struggle filling in the math. So you got to just do them. All right. I'm going to stop this video because it's 9 minutes, and that's just going to be rhombuses, and then I'll do rectangle.